Now I want to tell you about one other applications of something that looks like a diode. So we learned that semiconductor diodes are what are called PN junctions. So that is two different kinds of silicon that are put together, or actually one piece of silicon that is chemically treated in different parts differently. And so you end up with these two different regions, and this is what makes our diode work. So to understand the physics of this, that's really like a physics grad school sort of thing. But I will tell you this: if you measure the IV curve for such a device, we know what that looks like, right? This is like just barely negative here, and then it goes through 0 and goes up kind of exponentially. So this is our diode curve, right? Now, if we shine a light on this junction, if we shine a laser on it or a flashlight or something like that, with real diodes, the case is opaque so that this doesn't happen. But in some, if you have an exposed PN junction, you can do this. If you shine a light on it, you can actually, you end up shifting this curve down so that it doesn't pass through 0 anymore. So it looks more like this. And let's draw an exaggerated version of it, I suppose. I'm going to erase this middle one. So if you shine a light on the junction, so this one is dark, this one is illuminated. Some interesting things happen. So first of all, you can see that if we don't have anything connected to the diode, if we don't let any current flow, that is I equals 0, we have a voltage that forms. So in other words, we have this diode just sitting here, we shine a light on it, we get a voltage between the two ends. This is called the open circuit voltage. If we connect the two ends of the diode together with a wire so that the voltage difference is 0, which is along here somewhere, we see that at this point we actually get a current flowing. So this is the short circuit current. So no other voltage source or current source is connected to this. This is just the PN junction by itself. So we can get this open circuit voltage, we can get this short circuit current. And when we put a load in between these, that is, we have some resistor between the two ends, that's going to put us somewhere else on this curve where we have a positive voltage and a negative current. That means we are actually getting a net power out of our diode. So it points all along here. We have net power out of our diode. So this is how a photovoltaic cell works. So this is the basis of photovoltaics. So you shine light on this PN junction. Depending on what's connected to it, you might get a voltage and no current, or you might get a current and no voltage, or you might get both. So the maximum power you can get is going to be at some intermediate voltage and current, right? Because if you're at this open circuit or short circuit case, your power is 0 because either your current or voltage is 0. The max power in this curve, so if we just redraw this part of the curve, the max power is going to be the area of some square like this, or some rectangle like this, where this area is the power out, where you have some V and I operating points of your photovoltaic cell. And by changing the load resistance, you can change, you can shift where this point is and optimize your power. So depending on the amount of illumination, you can shift this curve down more or less. That has a larger effect on the current, so I'm moving these up or down, has a larger effect on the current than it does on the voltage. You know, shifting this curve up and down moves the voltage back and forth a little bit, but not all that much. You also, for a photovoltaic cell, they also can be operated like LEDs. So this is one way of characterizing how well a photovoltaic cell works. So up here, if you put power into your cell, you can generate light. And for typical photovoltaics, this is usually in the infrared, so you can't see it. But if you have a system for measuring that, you can use that to characterize some things about the efficiency of your solar cell. All right, so this maybe doesn't provide much insight into how they work, but it should give you some idea of how they need to be used in circuits. Because if we're not drawing any current from it and just having an open circuit voltage, no current flowing, right? Again, I wanted to emphasize that is no power, because if we're up at this point, the area of this rectangle is 0, right? Or if we're at this point, the area of this rectangle is 0. It's only for some intermediate voltage and intermediate current, both of those less than the open circuit voltage and the short circuit current, that we get a net power out of the system.